All right, so today I'm going to talk about a calcification of soils. So this is when you have a soil, you add calcium, and you have a problem where you have too much calcium. And so removing it is kind of complicated. So in this lecture, I'm only going to add about what happens when you add too much and some preventative measures that you can take to prevent from adding too much and alternatives you could use um, to having to add large amounts of calcium. So basically, it's gonna start out talking about um the problem. It's gonna talk about the solution. Then I'm gonna go in depth on how plants actually use calcium, some sources of calcium and their costs. Um, and at the very end, there'll be some photos to look at. The mostly is just writing. There's a few photos, but it's mostly just typed. I tried to make this as original as possible. I used online sources, but I was sure to paraphrase everything so I don't need to cite anything. Um, so let's begin. Okay. So on this first slide, we have gypsum, calcium oxide. So basically, we're talking about in this lecture is going to be all about um, the Brazilian rainforest region. So this is the area that we're discussing today. So basically, when you have an acidic soil, you want to either find some way to make it less acidic, either through improving drainage, um, adding more more material such as like um as we discussed in compost, there's browns and greens, high carbon and high nitrogen. So you want to add a mostly high carbon because if you have a higher carbon content, that will kind of not necessarily neutralize, but it will reduce the amount of um of nitrogen in the soil compared to the carbon. And if you have more carbon content, that improves soil structure. You get more aeration. So that's really the best way to deal with um deal with acidic soil if you were going that route. Um, so definitely you want to add more brown material such as decomposed straw, especially decomposed leaves, decomposed brown leaves like brown um sycamore leaves or any large brown leaf that decomposes that really improves soil structure even though it takes years to make a good compost, a brown compost that will take a really long time. Once you have that, it'll be a very useful product. Another one, especially in the tropical regions, is coconut coir. So coconut coir is another brown, and it's not too high in nitrogen, so that will also help. The only thing about coconut coir is that it kind of holds a lot of moisture in, um, but it could help um relieve some of the it can improve the ratio, to prevent too much acidification. So let's discuss more on calcium. Let's see. Next slide. Oh, here we go. Okay. Oh, it was these buttons here. Okay. Okay, so some of the causes, let's go over a little bit on what causes this problem. So Brazil contains, I'm gonna read the slide and then I'll go over what it says. So Brazil contains vast amounts of deforested land. This land receives a lot of rainfall. This also causes a lot of acidification. So as a temporary solution, farm employees or farmers add calcium carbonate calcium nitrate or any similar not molecule to attempt to solve the problem. But this often backfires, and the plants begin to suffer from different problems, especially of minor nutrients like iron, iron, phosphorus, um, and not mentioned here, molybdenum. And then basically a plant can't absorb any nutrient if the calcium level is too high, because calcium is a salt in most forms, not the carbonate, um, but the nitrate, that is basically basically um what it is a type of salt. So if this happens and plants get too much calcium in any form, whether it be carbonate or nitrate, the plant may die or be useless as a crop. Um, and if this happens in Brazil, then that country will need to import more food that will weaken the economy and life in that nation. So I'll go on to the next slide. So the pros and cons of adding calcium. So calcium is relatively inexpensive compared to other fertilizers. So you can get carbonate calcium or carbonates pretty easily, and there's not too much industrial process because you could, for example, um, go to a chicken farm, like a free range chicken farm, and you could like go out into the pasture where they have the chickens and pick up all the eggshells, or use like a vacuum that will pick them up. Of course, all the chickens are elsewhere, so the chickens don't get sucked up by the vacuum. Uh, or you could just pick them up by hand. Probably the best way is by hand. So you just have people going by hand, pick up all the chicken shells that broke, or you can use all sorts of other animal sources like well those have a lot of phosphorus, but chicken eggshells are the best example for like what something that you would like actually like see at your house that's in your house that you could look at. But there's also many other sources, especially mining. So mining is a little a bit of a problem, but we'll discuss that in the cons, not right now in the pros. So it's beneficial in small quantities if you add some calcium, especially for the brassicas. They love having a little bit of extra calcium, and they actually also like having a little bit of a slightly um um basic or non-acidic soil. They really like having like a little bit of gypsum or another material in their soil because there are we'll discuss it later why it is. Uh so shipping and handling, you might have to ship your calcium. You might have to shift the calcium kind of far to get it where you need it. And mining in the US is expensive. There's labor laws um in first world nations adding to costs. And then over adding will lead um to crop failure until the calcium is neutralized, which is very difficult. But we're not going to discuss how to neutralize calcium. We're mostly going to talk about alternatives to adding so much calcium in the first place. However, in some cases, you will find soil that already has calcium in it, and that is a different story. So, plants, uh, the main use of calcium is one last thing. So basically the way to neutralize the calcium is not necessarily to remove the calcium, but you can leach it through water. That will actually remove the calcium. But if you don't want to remove the calcium, because let's say you spend a lot of money on that calcium, you might want to add a lot of all the minor nutrients, or just add crushed rock in general that will contain all the minor nutrients. Maybe also a little bit of potash, but maybe you want to leach that calcium out, and that's the main thing you want to do, because there are some complicated forms of removing the calcium, but we're not going to discuss those here because they're simply too complicated. Um, so we'll continue. So how plants use calcium. So the main use of calcium is inside of the cell. Um, so basically, so animals, we have kind of like a more organic kind of shell cell shape. It's kind of like a rounder, um, more like looser cell that is meant to be able to kind of like grow and stretch. Whereas a plant cell, it kind of well, it does grow by all means it grows at some rate, but it kind of retains its shape, whereas humans cells kind of tend to, or animal cells tend to kind of change shape as the animals grow. So that's a major difference between plants and animals, is that the animals we have um less rigid cell barriers between the cell walls. We don't call them cell walls, but cell membranes or cell um edges. Whereas the plants, they have very a rigid cell wall. And also some plants have a very strong cell wall, and those plants are tend to be the brassicas. And the reason they need this is because they usually have a very tall or strong structure that needs this to hold the plant in place. Um, so for example, like a tall brassica, like a Brussels sprouts or a broccoli, needs a strong stem to support the large um flower bud at the top, or on the or in Brussels sprouts case on the sides. Um, but either way, you need a lot of calcium to have a very strong non-woody plant, because a woody plant will have like a carbon as its main structure holding it up, but a brassica doesn't really have like hardwood like a tree does. It has it's fleshy on the inside, but it's rigid at the same time. Uh, so it needs something to hold it in place. Um, so basically, plants needing the brassicas needing this makes them a very versatile plant, because they're one of the plants that is most high in calcium. That's why in certain places where there's less cattle, whether that be goats or larger cattle like cows, uh, regardless of the type of cattle that they don't have, they need to have something that provide them with calcium. And most foods like for example rice or um like various types of grain don't tend to have as much calcium, nearly as much calcium as the brassicas. The brassicas have the most calcium of perhaps any plant group. So they're very versatile in the aspect, especially for adolescents who are entering their the stage where they grow in height the most. Those plants are extremely important. Um, so that's one of the main that's perhaps the main reason why plants use calcium. So now we'll go on to the next slide. So more on how plants, these are a bit more complicated uh uses of how plants use the calcium. So the intercellular messaging is very complicated, but it involves how a plant breaks down um the calcium carbonate, or maybe there's some bacterial process before that will get the calcium into a more usable form. And so once you have Ca2 plus, the plant's able to use that to message with other plant cells within the organism within the same plant. Um, so it's kind of complicated, so I'm not going to discuss it here more than that. But here is the nutrient catalyst, and that's to carry nutrients um, to other parts of the plant. That says to other plants, no, it's carrying nutrients. So it either carries messages, or it's used for messaging, or it is um, used for carrying nutrients. So I guess this is kind of complicated too. So I guess it attaches the nutrients and moves them other parts of the plant. And also that's why I put these symbols here. These are not have to do with the plant itself, but they're kind of like analogies So here's like messaging. I put like a cell phone tower for messaging, and here for catalyst, I put a car for carrying. So now we'll go on to the next slide. So how plants use calcium? So for aeration, so calcium connects to binds to organic matter, such as clay, which will reduce soil compaction in areas with heavy clay, and this is called aggregation. And this again uses Ca plus plus or Ca2 plus. So Ca plus plus or Ca2 plus stimulates root development either from calcium that's already in the plant or from the contact of calcium on the outside roots. So in transplanting the shoots of plants, especially those that have that need a long taproot, um, the root tip of the plant is covered or inoculated with calcium to promote to cause the taproot to grow longer. So here's the last official slide. So it's about nitrogen fixation. So plants, this is kind of complicated, but again, it has to do with that signaling or messaging we discussed earlier. So plants use calcium molecules, I guess Ca plus 2 plus, but I'm not sure 100% what calcium molecules they are. But they're using these molecules to signal with the nearby rhizobium bacteria that are in the soil. So these are the bacteria that create that convert uh nitrogen that's in the soil, I guess, in terms of um nitrates and convert them into something the plant can use, or not, maybe not nitrates, but they convert nitrogen that's in the decaying organic matter, where that be nitrates or any other form of solid nitrogen. And well, anyway, they take they have, through a complicated process, they take what was atmospherical nitrogen that got decayed to organic matter. So they take the nitrogen from the organic matter. I'll have to do some reviewing on this, how it's done. Uh, but they take this nitrogen and then they give it to the plant. But these rhizobium need a place to live, so they live in these complicated looking nodules, which are like porous, kind of like crumbs. They look like little breadcrumbs. So a picture of breadcrumb, it has a lot of little holes in it. So the bacteria can live in all those little holes, and they could grow and reproduce there, and that will increase their population of those bacteria, and there'll be more bacteria, and then they will contribute to more green growth in the plant, because nitrogen is very essential for for chlorophyll production, um, so for photosynthesis. So basically, the calcium is used as a messenger again to communicate with these rhizobium bacteria. And when the plant knows that the rhizobium are prevalent in large numbers, then the plant will begin on its nodules to build houses for those rhizobium. Here are some of the effects of a lack of calcium. So you'll have like leaf curling, browning of leaves, decolorization. Um, here are some preventive tactics that can be used to prevent from calcium overuse. Here is some more on the alternatives, and that is the end of the presentation. So basically, I'm not talking too much about chemical ways of removing the calcium, but rather like drainage, sustainable agriculture. I'm talking about you maybe using rock dust. So basically all sorts of different ways of maybe not using as much calcium, because the main thing is you don't want to add too much calcium in the first place, not only because you lose a lot of money, but also because you don't know what effect it will have on the soil. Except after you read this, you know it'll have a very negative effect if you add too much. Because once you add too much of something that can't leach away very easily, or it kind of stays in the soil for a long time, you like a metal such as calcium, you are ending up with a lot bigger problem than, let's say, it was just that it was just like, let's say, nitrogen in the soil, which you could probably eliminate pretty quickly if you had too much nitrogen. Um, but if you had too much calcium, it's a lot different story. It's very hard to remove the calcium um, in some cases. And if you live in a place that already has calcium in the soil, that's even harder to do because oftentimes there might even be like um, a bed pan, a hard pan of calcium rich rock under the ground, and that'll like not only prevent plants from growing, but it'll prevent like tree roots from even breaking through. Um, so yeah, calcium can be a major problem, and you really want to look on finding a good location for to grow your crops. If you can't grow in the soil, then you might have to like build the raised beds um out of not cardboard, but like composite wood it's been glued together, because you don't want to use hardwood because not only is it unsustainable, but because it'll be so expensive, so you want to use the cheapest kind of wood as possible. um and it's just a complicated process. So basically the best thing you can do is find a location with not too much calcium and not too much acidification to begin with. um and as discussed at the end of the slide, um if you want to prevent it in the first place, you might want to not, if you have land with lots of rainforest, you might not want to cut down the rainforest. You might actually want to plant trees in between the rainforest so that you're not upsetting the existing ecosystem. Because the existing ecosystem doesn't suffer from as acidification as the deforested land does. Because when it gets deforested, there's a lot less. It's a very complicated process, but there's um a lot less protection from the rain as a canopy provides, and there is less there's less nitrogen in the soil because so much of it is in the plants. There's less carbon in the soil. So although it's not maybe a lot poorer soil than if the trees were removed and fertilizers were added, there is enough nutrients to grow like plants such as cacao or chocolate. Um, and yeah, that's basically the end of the presentation.